You know that question we always ask ourselves when we look at the stars. What's out there? In 2017, we received a messenger, a strange object that nobody really understood. Oumuamua. Then, in 2019, came a comet that even seemed like one of ours, 2I/Borisov, which gave us a peek into a distant solar system. And now, it happened again. It's official. Scientists confirmed the arrival of 3I/Atlas, our third visitor from another star. But this one, it's different from everything we've ever seen. And what it's starting to tell us about its home could change everything we thought we knew about how solar systems are born. To understand the magnitude of what's happening, let's rewind. First, we had 1I/Oumuamua, which in Hawaiian means something like the first messenger from afar. And what a bizarre messenger it was. It had a strange shape, maybe like a cigar, maybe like a pancake, and it didn't have the tail of gas and dust we expect from a comet. Its trajectory was, without a doubt, from outside our system, but its nature remains a mystery. 2 years later came 2I/Borisov, and that one was much more well-behaved. It looked and acted like a comet we already know. It had brightness, it had a tail, and its composition, even with some little differences, was clearly that of a comet. Borisov showed us that comets like ours exist out there, around other stars, an important piece of the puzzle. So, first came total mystery, then something familiar and comforting. And now? Now we have 3I/Atlas, which doesn't quite fit into either of those two boxes. It seems to mix the enigma of the first with the science we can study from the second, creating a simply unique opportunity. It all started on July 1st, 2025. There in the data from the Atlas program, a system that keeps an eye on dangerous space rocks, a dot of light caught attention. It was moving at an impressive speed, right at the border of the constellations of Sagittarius and Serpens Cauda. At first, it was just another one on the list, with the provisional name A11PL3Z. But astronomers, both professionals and amateurs, immediately realized there was something very strange about its orbit. The object was traveling at an absurd 38 miles per second. That's more than 136,000 miles per hour. The big turning point in the story came when they calculated its trajectory. Think of the sun's gravity like a well. Objects in our system, like planets and comets, are trapped in this well, spinning in circles or ellipses, like a marble inside a bowl. But Atlas wasn't spinning. It came in an almost straight line toward the sun and with so much speed that the sun's gravity can't hold it. It's going to take a plunge, make the curve and be hurled back into interstellar space, never to return. This is a hyperbolic orbit, and Atlas's is one of the most extreme ever seen, with a very high eccentricity. This was the final proof. It wasn't ours. It was an immigrant coming from another sun. Okay, it came from far away. But what is it? The first images already gave a hint. Unlike Oumuamua, Atlas had a kind of diffuse glow around it, a coma. Soon after, more powerful observations confirmed. It has a tail, faint but undeniable, over 15,500 miles long. Without a doubt, 3I/Atlas is a comet. And this is where it gets even cooler. A comet's tail isn't just pretty, it's a message. As it gets close to the sun, its nucleus, which is a ball of ice, rock and dust, heats up. The ice turns to gas directly without passing through liquid, and this gas drags the dust along, forming the coma and tail. When we point a telescope at this tail and analyze the light passing through it, we can read the chemical composition. It's a technique called spectroscopy, which works like a cosmic barcode reader. Analyzing 3I/Atlas is literally like reading a chemical postcard sent from a stellar system we don't even know. The gases in its tail, water, carbon dioxide, maybe even organic compounds, are direct samples from the cloud of gas and dust where it was born. They're the same ingredients that form the planets in its system of origin. Comparing this with our comets, we can start to answer incredible questions. The journey of 3I/Atlas is as incredible as its composition. It came from the direction of Sagittarius, near the center of our galaxy. We imagine it was ejected from its system of origin by a gravitational push, perhaps from a giant planet, and traveled through the void for millions, perhaps billions of years, until arriving here. Its trajectory through our backyard is also impressive. It's coming from above, at an angle of almost 175 degrees relative to the plane where the planets orbit. The closest approach to the Sun, perihelion, will be on October 29, 2025, when it passes about 124 million miles from our star, a bit beyond Mars's orbit. At that moment, its speed will be over 37 miles per second. Before that, in October, it will pass relatively close to Mars, which is a golden opportunity for the probes that are there to observe the comet from a privileged angle. The closest approach to Earth happens in December 2025, but at a super safe distance of about 168 million miles. And its size? This is where Atlas impresses again. It's difficult to measure the solid nucleus because of the gas cloud around it, but the first estimates point to a diameter of 2.5 to 3 miles, possibly much larger, maybe even up to 12 miles. To give you an idea, this is much larger than Oumuamua and Borisov, and perhaps several times larger than the asteroid that wiped out the dinosaurs. Atlas isn't a little interstellar pebble. It's a mountain of primordial ice wandering between the stars. This ability to analyze distant worlds that come to us is one of the most fascinating things about astronomy today. It's proof that the universe is a dynamic place, all connected. If you agree and are as impressed as I am, you know what to do, right? Leave that like on the video. And to not miss the next chapters of this saga, subscribe to the channel and turn on the notification bell. Okay, but so what? Why is this comet so important? Each visitor like this is like finding a torn-out page from a book we didn't know existed. Oumuamua was a blank page, full of mystery. Borisov was a page that showed us that other books can be similar to ours. Atlas, perhaps, is the first detailed paragraph we can read. A generous sample from another cosmic neighborhood. The fact that we detected it so early, long before its closest approach, is a gigantic advantage we didn't have with the others. This gives scientists time to point the biggest and best telescopes in the world at it, both on Earth and in space, like the James Webb. The goal is to squeeze every drop of information from every photon of light coming from it. The arrival of Atlas confirms what astronomers already suspected. The space between stars isn't empty. It's full of these travelers. And with the new observatories that are about to start operating, like the Vera C. Rubin Observatory, we expect that finding these objects will become routine. We could go from a few per decade to dozens per year. We'll start to build a catalog of neighboring stellar systems without even needing to leave home. 3I/Atlas isn't just the third visitor. It's confirmation that we've entered a new era of space exploration. It's the first major sample from a comet nursery of another star, an ice fossil that traveled for ages to tell us its story. And with each messenger like it, we assemble one more piece in the puzzle of how our own existence on our pale blue dot fits into this giant cosmos. The big question used to be, are we alone? Perhaps the most important question now is, what are our neighbors like? And Atlas is starting to give the answer. The question isn't if we'll have a fourth visitor, but when we'll find it. Now I want to know from you, what type of star do you think Atlas came from? From a giant star that kicked it far away with force, or from a system with two stars, all chaotic? Leave your theory here in the comments. Let's continue this cosmic conversation.